Okay, we're going to go over the final review today for polynomials. I'm going to go through a few of the questions with you, but I'm going to leave some for you to do as well, answer the questions as we go along, and I'll give you some tips on the ones that we don't do. Okay, from the first section, this says evaluate each function. I'm going to work on number 2 with you. It says p of x equals x squared minus 1. Find p of negative 5. So since this negative 5 is plugged in, that means that we have x equals negative 5. So that means everywhere there's an x, I'm going to fill that in with a negative 5. So if we rewrite our equation, p of negative 5 equals negative 5 quantity squared minus 1, we can just solve that. So negative 5 squared is 25, minus 1 is 24. Okay, so this is going to be 24, which means that that is my final answer. And we would perform the same type of thing for number 1, except the number that's getting substituted into the function is negative 10. On number 3 and 4, we're given the function, and now it's saying solve for x if h of x or if f of x equals a number. So it's not telling me f of the number this time. So that means I don't have x equals the number. Instead, I have f of x equals the number. So that means this gets plugged, or this gets set equal to the equation. So right here, I have f of x and f of x. I can set each of those things equal to each other. So I have 2x squared plus 4x gets set equal to 48 from over here. Now this looks kind of like a quadratic, but it's not exactly a quadratic. In order to solve that, I am going to rewrite this. Okay, I don't have a c term, so I'm going to leave that as 0. I have equals 48. Now, if I subtract 48 from both sides, I get 2x squared plus 4x minus 48 equals 0. Now, I can solve this. It's a quadratic in the form of ax squared plus bx plus c. So that means I have to first find the GCF, if there is one, and then second, factor by grouping. So this does have a GCF. All of these numbers are even, which means 2 is the greatest common factor. So I have 2 times x squared plus 2x minus 24 is all equal to 0. Now, I can make my t over here what multiplies to negative 24 and adds to 2. I can check a couple of things. If I try 8 and negative 3, that's 5, that doesn't work. If I try 12 and negative 2, that's 10, that also doesn't work. Let's see if I try 6 and negative 4, that multiplies to negative 24 and adds to 2, so that is going to be those are going to be the numbers that I choose. Now, my GCF stays, and now I have x squared plus 6x minus 4x from my t minus 24, and that still equals 0. To factor by grouping, we like to split it down the middle, and now divide by each of these GCFs. So the GCF of this left-hand side is x, and the GCF of the right-hand side is going to be a negative 4. So my 2 stays. Then I have my x of my GCF left. Now x squared divided by x is x. 6x divided by x is 6. Okay. Negative 4x divided by negative 4 is going to be just a positive x. negative 24 divided by negative 4 is going to be a positive 6. And this is what I'm left with. So to finalize my answer, to finish simplifying, I have 2 times x plus 6, and that comes from here, times x minus 4, and that comes from the GCF that we had just factored out. So that's right here. Okay. Number 3 would be similar, but if it's a quadratic, we're going to do the same thing. If not, just solve for x. Okay, 5 and 6, they perform the indicated operation. Okay, well, what operation are we using for number 5? What is that operation? Since it's subtraction, that means I need to distribute my negative 1 through the whole right side of the parentheses, or the second side of parentheses. Okay, so I'm left with negative, and I'm going to get rid of these parentheses now, negative 7n cubed plus 8n to the 4th plus 5. Then minus a negative is plus 3n to the 4th. Minus a negative again is plus 3. And minus that last negative is plus 7n cubed. Now, let's see if I have any like terms. I have a negative 7n cubed and a positive 7n cubed. Well, that actually is going to become a 0 pair and cancel out. The next thing I have is an 8n to the 4th and a 3n to the 4th. Well, I have a positive 8 and a positive 3, so that leaves me with 11n to the 4th. And then finally, I have a 5 and a 3, and those are just constant terms, so 5 plus 3 is 8. So here will be my final answer. For number 6, what operation are you going to use? This one is addition, so we are just going to add all of the like terms, combine them as is. There's no reason to change any of the signs. Okay. 7 through 10 have the same directions. We're going to perform the indicated operations for these ones. So they're all multiplication. These are all different kinds of multiplication. Now you might use the box method. That's what some of you use. You might use your regrouping method, like this. You might use FOIL, which is first, outer, inner, last. Whichever method it is that you use, that's what we can do for these 4 problems. Now, the way I am more inclined to show it is using the box method. So for number 8, this is going to be one of the more difficult ones. Okay? I have 2 terms over here and 3 terms over here. So that means my box that I'm using to multiply is going to be a 2 by 3 box. So I am going to have 2 rows and 3 columns. So down I have 5n minus 4. And across I have 4n squared plus 3n minus 3. Now, in this first box, that's going to be 4n squared times 5n. Well, 4 times 5 is 20, and n times n squared is n cubed. That leaves me with 3. If we keep going across the top, 5 times 3 is 15, so 5, we're doing this one now. 5 times 3 is 15, whoops, and n times n is n squared. And then finally, I have negative 3 times 5n. Well, negative 3 times 5 is negative 15, and then I just have an n. So I have negative 15n. Now, if we go down to our second row, I have 4n squared times negative 4. Well, I have 2 coefficient terms, so negative 4 times 4 is negative 16. And then I'm left with an n squared. Down the middle, 3n and negative 4. 3 times negative 4 is negative 12, and I'm left with an n. And then finally, negative 3 and negative 4 is going to give me a positive 12, because a negative times a negative is a positive. So now all I have to do is combine like terms. So I have 20n cubed. it doesn't have any like terms, so that's going to just be 20n cubed. Okay, and the next I have a 15n squared, and I actually do have another n squared. So 15n squared plus negative 16n squared is going to give me a negative 1n squared. If I keep going, negative 15n and negative 12n. So that's two negatives, so I'm just going to get a larger negative. So negative 15 and negative 12 is negative 27n. And then finally, I have a 12 for my constant term. It has no like terms, so I'm going to write a plus 12. So that's going to be this final answer. Okay. Now, 7 and 9, I'm going to skip those ones because you all are pretty good at those. Number 10 is the one that I am more concerned with. So I want to see, what do you do? What do I do with the square? What does the square mean? Okay. Now, a lot of you distribute the square through, and you get 49b squared plus 16. That is not going to be your right answer, okay? Because the 7b plus 4 quantity squared means that I have 7b plus 4 times itself. Oops. Okay, so if I wanted to multiply that, I could set it up in a box, or in the grouping, or in the FOIL, whichever method you prefer. So I'm just multiplying the same thing by itself. Okay, so 7b times 7b is 49b squared. 7b times 4 is 28b. In the bottom row, 7b times 4 is 28b. And 4 times 4 is 16. So if I simplified, if you had just done the original distribute the square through, which is incorrect, you would have been missing, these two middle terms right there. You got the 49b squared and the plus 16, but you didn't get the rest of them. So this final answer is going to be 49b squared plus 28 is 56b plus 16. So that will be this final answer. And then 7 and 9 can be solved the same way. (11) through 13 are also performed the indicated operation. So I want you to tell me what are the correct operations for 11, 12, and 13. I want you to answer that question right now. Okay. Number 11 is addition. Number 12 is subtraction, and number 13 is multiplication. Remember that closed circle means multiplication. That's not composition. It's not an open circle. Okay? So this addition tells me that I can rewrite this as g of a plus h of a, and then solve. Okay? So I can write 3a minus 1 plus 4a, and just combine those like terms. Okay, now I want to look at number 12 because that one has something different. Okay, this one has numbers in place of x. So the way I would solve this is substitute that number back in to the equation. So I'm going to look for g of 2 equals 4 times, and then everywhere there's an x, I'm going to write 2 minus 2. So I have 8 minus 2 is 6. Now this is not composition, it says subtraction. So I'm going to perform the same thing for both of my functions. So h of 2 equals negative 4 times 2 minus 5. Negative 4 times 2 is negative 8 minus 5 is more negative, so I have negative 13. Now, this is g of 2. 6 is g of 2, so I can substitute that or replace it. h of 2 is negative 13. So that means I have 6 minus negative 13. And remember, when you subtract a negative, it becomes addition. So that final answer will be 19. 13 would be done the same way, but using multiplication instead. 14, 15, and 16 also say perform the indicator operation. This time they are division. So for number 14, which method is the best one to use? Is it going to be synthetic division or long division? Okay, number 14, we can use synthetic division because when I set my factor, I have x plus 1 equal to 0. That means my root is negative 1. It's a whole number. It's not a fraction. So when it's not a fraction, I can use synthetic division for this problem. So remember, to set that up, we have our little box. And we're going to write our coefficient terms across the top. So this coefficient is 1, 9, 2, and negative 6. And the root is negative 1, so that's going to go up here. So I know this is really old. We've been doing this for a while. First, I'm going to bring down the 1. Then I'm going to multiply. So 1 times negative 1 is negative 1, so that's going to come up. 9 minus 1 is 8. I'm going to multiply. 8 times negative 1 is negative 8. I'm going to add down. 2 minus 8 is negative 6. I'm going to multiply. Negative 6 times negative 1 is positive 6. I'm going to bring that up. And negative 6 plus 6 is going to give me 0. So since 0 is that final number, that means this question has no remainder. Now, if it was, let's say, 2, that means there's a remainder of 2. However, this one is 0. So the way I write this without a remainder is I see that my highest exponent is 3. One less than that is 2. So that means each of these numbers that I got will become my new coefficient. So I have 1x, now it's squared, plus 8x, because each exponent is 1 less, minus 6. If you had a remainder, you would say plus 2 over the original factor. But this one did not actually have a remainder, so we would just leave this as our final answer. Or you can write x squared plus 8x minus 6 as your final answer. Now 15, are you going to use synthetic or long division for that one? Okay, that one is synthetic. Make sure you check if it has a remainder. If it does, you need to include that as your answer. Now 16, I have 3m plus 7. That is different from the other two. If I set that factor equal to 0 and solved, I would get a fraction. So that means that on this question, I have to use synthetic division. Okay? So, in order to do synthetic division, long division. In order to do long division, I have to set up the entire problem. So I'm going to start that up at the top. And I have like this. 27m cubed plus 75m squared plus 37m plus 12. And then the 3m plus 7 comes out front. Now I'm going to cover up number 16 so that I have room to write, and you should have it on your paper anyways, or what you're looking at. So to solve this, the first thing I need to do is I am always going to be multiplying this value, the 3m times something. So 3m times what is going to get me 27m cubed. Okay, so 3m times, 3 times 9 is 27, and m times m squared is m cubed. So that means I have 3m times 9m squared is 27m cubed, and 7 times 9m squared is going to give me 63m squared. Okay, so I like to put that in parentheses and then subtract the whole thing. So that means I'm going to subtract and subtract. Both of my signs change. So 27m cubed minus 27m cubed is 0. 75 minus 63 is going to give me 12, and then m squared stays the same. That doesn't change because I'm just combining like terms. Then I bring down the 37m. And I'm going to repeat. So 3m times what is 12m squared? Okay, so 3 times 4 is 12, and m times m is m squared. So that means I have 12m squared plus 4 times 7 is 28m. And I'm going to put that in parentheses again. And now subtract. So this means I get a negative and a negative, so these both change signs as well. 12m squared minus 12m squared is 0, and 37 minus 28m is going to be 9m. Okay, so I have a 9m, and I'm going to bring down the plus 12 that I had. And finally, we're going to repeat this one last time. It looks like this will be the last one. So 3m times what is 9m? Okay, 3m times 3 is 9m. So I'm going to bring down a 9m. And then 3 times 7 is 21. Now if I subtract, 9m minus 9m is 0. And 12 minus 21 is negative 9? Yeah, negative 9. Okay, so 3m, I can't multiply anything to get negative 9, so that means this will be my remainder. So to write my final answer, I have 9m squared plus 4m plus 3, and then with the remainder, I'm going to write minus 9 over 3m plus 7. Okay, that's the final answer. Moving on. Number 17 and 18 say write as a product of linear factors. So remember, this just means write in factored form. So this first step to factoring is what? What's the first step to factoring? Okay. It's take out the GCF. The second step then is to group. So that means split it down the middle. So let's look at number 17. Is there a GCF for these terms? Does 17 have a GCF? Okay. If I look at 17, 2 goes into these first three numbers, but it doesn't go into 7. And 7 doesn't go into 8b or into 32b cubed. So this one actually doesn't have a GCF. So we're going to start our first step by just splitting it down the middle and then taking out the GCF. So on the left-hand side, okay, this GCF, I can have a number, I can have a variable, or I can have a combination of both. In this case, I do have both. So what number goes into both 32 and into negative 28? Okay, that number is going to be 4. Okay, so 4 goes into both, but then I do have a variable term. So I have 3 b's and 2 b's, which means at most I can factor out 2 b's or a b squared. Now on the right-hand side, let's look to see if that one has a GCF. So 7 is a prime number, so its only factors are 7 and 1. So the only factors that negative 8b and 7 have in common are 1 or negative 1. Now, since this is a negative and this is a positive, so on the left-hand side it was a negative and on the right-hand side it's a positive, that tells me that I'm going to take out and negative 1. So if I finish solving this problem, I have 4b squared times 32b cubed divided by 4b squared is 8b. Negative 28b squared divided by 4b squared is negative 7, sorry. And then on the right-hand side, negative 8b divided by negative 1 is going to be a positive 8b. And then positive 7 divided by negative 1 is going to be a negative 7. So I'm left with 8b minus 7 times 4b squared minus 1. Now, am I done solving this problem? You should have said, no, I'm not done solving this problem because I'm left with 4b squared minus 1. Now, remember, that's a difference of 2 squared. 2 squares. So the first term can I can take the square root of that, and the second term I can as well. So if I'm looking for the square root of 4b squared, okay, the square root of 4 is 2, and the square root of b squared is b, and the square root of 1 is going to be a 1. So that means I have 2b as my first term, 1 as my second term, and plus or minus, so that's how this factors. So that means my final answer is 8b minus 7 times 2b plus 1 times 2b minus 1. Okay? And this will be the final answer. Now on number 18, what is the GCF if there is one? Okay. Most of you, I'm sure, got 2, because 2 goes into both 4 and into 2. But there is also an x, an x, an x, an x. All 4 of those terms I can take an x out of. So the GCF is actually going to be 2x. So I have 2x times 4x to the 4th divided by 2x is 2x cubed, minus 4x cubed divided by 2x is 2x squared, negative 2x squared divided by 2x is negative x, and 2x divided by 2x is plus 1. And from here, you can continue to solve and factor by grouping. Let's look at the next set. Okay, this is write as a product of linear factors and find all the roots, zeros, x-intercepts, and solutions of f of x equals 0. So earlier in the problems, I actually showed you how to factor. So I'm not going to factor number 19 for you. I'm just going to give you the factors. I need you to do the work, okay? So the work will be up here, but I'm not going to go through it. So type in your factors, and then you'll be able to proceed. Okay, so here are the factors if you need to look at the work. This is what I've done. But I can set this equal to 0. So what I can do is set each factor equal to 0 in order to find the roots, the zeros, the x-intercepts. So subtracting 1 from both sides gives me x equals negative 1. So that's one of my roots. I'm going to do that on the other side as well. For the other factor, I get 3x equals 5. Divide both sides by 3, and I get x equals 5/3. Now, that means I have x equals negative 1 and 5/3 as my roots, as my zeros, as my solutions. But if I'm looking for x-intercepts, remember, that's only the x value. The y value is 0, so an x-intercept should be written as a coordinate pair. So that would mean I have negative 1, 0, and 5/3, 0. So that would be my x-intercepts. Okay, number 20 can be done similarly. Make sure that you check to see if there is a GCF to begin with. Okay, moving on. I have 21 and 22. The directions are write as a product of linear factors and find all root zeros, x-intercept solutions, given that x plus 3 is a factor of the polynomial. Okay, so I see x plus 3 is a factor. That means I have to do x plus 3 equal to 0 to find what this root is. Now, once I have that root, I can perform synthetic division, which I've already done. Okay, I've already showed you this, so I'm going to skip to the part with the rest of the work. Now, number 21 is done the same, except I'm given a 0 to begin with, so I can just do synthetic division from the very beginning. So here's how we would set up the problem, and now we are going to solve. Actually, before we solve, I made a mistake. Let's look at this real quick. I have 5x to the 4th. I have another x, I have another x, and I have another x. So before I keep going, I do have a GCF of x, so let me factor that out. So I have x times 5x cubed plus, let me fix that x, 5x cubed plus 29x squared plus 39x minus 9. And those coefficients or those numbers are still the same, but I did want to make sure that I factored out that x because it will be a part of our answer in a minute. Okay, once you do your synthetic division, you should get to this step. So we write our answer 5x squared now because cube is our new leading degree. So I have 5x squared plus 14x minus 3. Okay, so I have the x that I factored out, the x plus 3 that was a factor, and this thing right here, which I can also factor. So I'm going to pause it again and continue to factor. So you should have 5x minus 1 times x plus 3 when completely factored. So these are two more factors. If I come back to my original, I can see that I should have 4 factors in total when I completely factor this. So if I count them up, 1, 2, 3, 4. Yeah, I have all of the factors that I need, and I'm just going to write it in factored form now. So I have x times 5x minus 1 times x plus 3 times x plus 3. And since I have two x plus 3's as factors, I can continue to simplify and write this as x plus 3 quantity squared. And then this all equals f of x. Now I want you to finish finding the roots, because that is another part of the problem, and then input your answer. Okay, remember that when we have x out front, that's an origin root at 0, and the other part is when you have a square, we can write multiplicity 2 or write that twice as a root. Okay, 23 and 24, they say list all intercepts of the function below. This is very similar to what we've been doing. I have 1, 2, 3 distinct factors, but 4 in total because of that square. So I have x plus 3. I can set it equal to 0 because I'm looking for intercepts. X minus 7. And x plus 1 equal to 0. And just remember that this has a multiplicity 2. So I'm going to subtract 3 to find my first one. I'm going to add 7 to find my second one and subtract 1 for my last one. Now, that is not your final answer. I'm asking you for the intercepts. What you've just given me is the roots, is the zeros, is the solutions. So type in what this would be in intercept notation. Okay, remember, the intercepts are number, comma, 0. Number, comma, 0. Number, comma, 0, and this one has 2 of the same thing. Don't square it, that's no good. You can write multiplicity 2 or write it twice. On number 24, will there be an origin root as the 0? Yes. It's going to be right here since there is an x factored out, and you're going to finish solving it the same way. Okay. Numbers 25 and 26 are asking about end behavior. So remember, that looks like as x goes to infinity, where does f of x go? And as x goes to negative infinity, where does f of x go? So for number 26, I actually want to classify the function because that will help me. So the first thing I see is a negative. So I know this has a negative facing, it's in the negative direction. And then I have 1, 2, 3. So third degree is going to be cubic. So I have a negative cubic. Now, if you look back at your toolkit, there are pretty much 4 different possible end behaviors. We have even and positive, even and negative, odd and positive, and odd and negative. So these are our 4 possible end behaviors. This is it's odd because it's cubic, and it's negative, so that means I'm looking at the bottom right. These are going to be my end behavior arrows. So as I'm coming in, as x is going to the right, so as x is going to positive infinity, where is y going? So if we look over here, as x goes to the right, y is going down, which means it's going to negative infinity. And then as x is going to negative infinity, or to the left, where is y going? Okay, so as x is going to the left, y is going up, which is to positive infinity. Number 25 has the same idea. Number 27 says sketch the graph of each function and list the key features. So that's for 27, 28, and 29. So our key features are classification and orientation. Classification and orientation. In behavior. And all of our intercepts. And I said all, which includes the y-intercept. Okay, so this classification is what? What degree is this polynomial? What's the name of it? Okay, so this is a 3rd degree, so it is cubic. This is a cubic, and is the orientation positive or negative? It is negative. Okay, so I have a cubic and negative. So I can tell what my end behavior is going to be because I know the arrows look like this. So as x goes to infinity, where does y go? That goes down to negative infinity. And as x goes to negative infinity. Okay, this all cleared on accident, so we're going to try this again. I have, as x goes to infinity, we said f of x is to negative. And then for the second one, as x goes to negative infinity, where does y go to? Where does f of x go? Goes to positive infinity. And our end behavior arrows also show that. Okay. So for my intercepts, I have x equals positive 2, negative 3, and positive 4. So that means I have my x-intercepts are 2, 0, negative 3, 0, and 4, 0, but I can't forget the y-intercept. So in order to find that one, I'm going to plug in 0 for all of my x's, because remember, the y-intercept has 0 for all the x's. So that means this becomes a 0, becomes a 0, becomes a 0. So I have negative 0 minus 2 is negative 2. 0 plus 3 is 3. And 0 minus 4 is negative 4. So negative times negative 2 times 3 times negative 4. Well, that gives me, let me move these end behavior arrows out of the way. That gives me negative 6 times negative 4, which is negative 24. So that's my y-intercept. So now I'm going to graph these. And that's obviously not going to fit on my graph as far as the y-intercept goes. So I'm going to graph the x-intercepts first. I have 2, 0, negative 3, 0, positive 4, 0, and then 0, comma, negative 24. I'm going to relabel this right here. I'm going to say that's at negative 24. Okay, so going to graph through, whoops, that is an ugly line. We're going to graph this. And that is our negative cubic. Now for number 28, I have multiplicity. So what does that mean as far as the x-intercept goes? How do I graph that if I have a multiplicity of 2? So multiplicity of 2, remember that means that I bounce. So since that intercept is at positive 1, we're going to highlight it or make it into a star or however you show your bounce on your graph. So 28 and 29 are going to be the same idea. Finally, we're going to finish with 30 through 33. So 30, I chose, actually I don't want to do 33. I'm going to do 32 instead. So I have 30 and 32. So it says, write the equation of the polynomial function pictured below. So what I really need to do is identify my x-intercepts. So that's at x equals negative 1, at 0, and at positive 2. So the way I write this is x equals negative 1 becomes x plus 1. X equals 0 becomes just an origin, or just an x, and x equals positive 2 becomes x minus 2. I'm going to say equals f of x, so that'll be my answer. On number 32, I only have 2 intercepts, but if you notice, they're both bouncing, which means I have multiplicity 2. So I have x equals negative 3, negative 1, and negative 1. So that means I have x plus 3 times x plus 3 times x plus 1 times x plus 1. Or this is better written as x plus 3 quantity squared, x plus 1 quantity squared equals f of x. Now, does 31 have a bounce anywhere? Yes. Does 33 have a bounce anywhere? Yes. And before you finish, let's go back to 30 because I did make a mistake. Let's look at this in behavior. It is going in the negative direction, so that means that my answer should have a negative. So I'm going to rewrite this answer a little bit more cleanly. So that means I have f of x equals negative, since it has negative orientation, x times x plus 1 times x minus 2. Does 31 have a positive or negative orientation? Okay, that's positive. And does 33 have a positive or negative orientation? That one's also negative.